Welcome back to the final video of our series for Microcomputer Engineering. This is Logan, and today we'll be working with a second IDE to develop a graphical interface which can be used to provide remote control over the launchpad or graphically display collected data. I find it unlikely you've made it to this point without having heard this numerous times, but if you are looking for contact or course information, refer to Canvas in the course syllabus. Open office hours for the lab will also be available on Canvas as well. To do today's lab, you must have completed the previous 4 labs and be familiar with controlling a servo and serial communication. As always, we'll be handling electronics today, so make sure to turn off any circuits before changing them, and take your time and handle components gently. If you have any questions, make sure to double check your work, but once again, if you're unsure about anything related to the lab, please reach out to me by email or during the open office hours. So before you can work through the lab procedure today, you will have to install the new IDE called Processing. The link is given to you in the lab manual, but otherwise I'll add a link in the video description and on the video itself. The installation is quite simple. Just download the correct file of your operating system and then extract it to a location that you can easily find. To make things easier, I also recommend creating a shortcut to the application. Just navigate to the executable file in the location you extracted the files to, right-click on it, and select Create Shortcut. This way you'll have an icon on your desktop you can just click rather than having to go through the File Explorer. Now, you may be wondering what processing is and why we're going to be using it in our lab today. Although microcontrollers like the TiVo Launchpad or Arduino Uno allow you to easily make an embedded system, they do not provide many possibilities for visualizing data that you've collected or the ability to easily make an interface on a host machine to control your device. With the rise of the Internet of Things in the last few years, it is becoming increasingly useful to be able to receive and interpret data from these devices. This is the role that processing fills. When you open the application, you will find it's similar to Inertia in the Arduino IDE, but is intended to write programs that remain on your host computer rather than being uploaded to a microcontroller. As such, it also includes a number of new tools, such as the debugger and terminal, which can be used in a manner similar to what we'd use the serial monitor for. Take a few minutes to look over the features of processing before starting the lab. In the first part of the lab, we'll be making sure that the TiVo Launchpad can communicate with processing by running a simple Hello World program. We must use Inertia to write the firmware for the Launchpad and processing to write the application for the host computer. Follow the steps in the lab manual to write the firmware. It's pretty simple since there are only 3 lines of code you must add. Once done, upload your code to the microcontroller. Next, we must create a new processing sketch that will read the incoming serial message. This will be similar to what you did in the previous lab on the Launchpad. In processing, we once again will be using 2 main functions, setup and drawing. These are identical to setup and loop in Inertia, but with drawing instead of loop. One runs at the beginning and the other runs continually in sequence. The one potentially tricky part of this section is specifying which serial port you'll be using to connect to the Launchpad. This changes largely due to operating system and has less to do with the COM port of the microcontroller. If you're on Windows, try port 1, and otherwise if you're on a Mac, try port 0. If this doesn't work, just try another integer or check the device manager. You'll need to look for Stellaris Virtual Serial Port and see what number this is. Once you finish this, run your code and you should see Hello World being printed out in the terminal. If you don't, you can use the serial monitor in Inertia to see if the Hello World message is being printed properly as a debug step. Make sure this part works properly before moving on, as we cannot continue with the lab without making sure this works first. Now that we know we can communicate with the Launchpad, we're going to collect and graph incoming data. Wire up the potentiometer as you have many times now, making sure to specify a pin that will work as an analog input. Follow the instructions in the lab manual to create a new processing application that can graph the data. We will be changing how we handle a serial message, this time using an event-driven approach. The program will operate normally, and when a new serial event signal is received, it will read the new message. Once you finish this section, you should be able to run the program on the Launchpad and the processing application will plot the data. If it is working correctly, you should see something like I have here. Feel free to play with the different colors and other parameters. You may also notice the potentiometer can be quite noisy, which is quite common for real-world electronics. This usually has to be considered when designing products, as filtering can be quite important. Finally, the last thing we will be doing with processing is making a very simple graphical interface to control the servo. This has applications in robotics where you can control a mobile robot using a GUI on a remote machine over Bluetooth or Wi-Fi quite easily. Today, all we'll be doing is making a simple button that can move the servo clockwise. You'll find that front-end programming can be a fairly long and tedious process, but quite straightforward. Follow the lab procedure to create your interface, and if you feel up to the task, also create a second button that moves the servo in the other direction. If you do this, you'll receive bonus marks as well. If it's working correctly, you should be able to move the servo using the GUI as I have done here. You may find it's a bit slow to react, as in my case, but this could be due to the USB hub I'm using. Once you finish the lab, fill out the lab report and take a video of your Part 3 and Part 4, which is the bonus, and upload them with your final code to Canvas. Thank you for following these videos through to the end, and I wish you good luck in your upcoming exams.